3D Pythagoras with adamonlinetutoring. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. In 3D shapes, Pythagoras' theorem is used to calculate missing lengths, usually a diagonal or a slanted line connecting 2 points in three-dimensional space, such as the length FD in the cuboid shown. F to D goes from here to here. We'll be able to use this right-angled triangle with a length going down from F to B and the other length running across the base in the same direction as FD. Pulling this two-dimensional shape out, which goes from F to B to D, and labelling the lengths which are known. The only one known is the length that goes from F to B, which will be the same labelled as G to C on this side, which is 3 meters. The overall question is asking us to find FD. To do this, I need to know the other unknown length which runs from B to D. That's a shared length with this right-angled triangle that runs across the base of the shape. If I pull this 2D shape to the side that runs from B to A to D, I can label this length across the bottom as 8, and I can label this length that goes from A to B as the same on the opposite side, which is 4. And this allows me to work out the length BD, which is the same as the shared length and the missing one required in the other triangle. Because it's a longer side opposite the right angle, I can find this by doing the square root of 4 squared plus 8 squared. This is the square root of 80. Rather than rounding this, it's better to keep this as an exact value. Root 80 is BD, which is the shared length down here. And now I can use Pythagoras again to find the hypotenuse of this shape. 3 squared plus root 80 squared, which is just the same as 80, is root 89. And rounding the length FD to 2 decimal places is 9.43 meters. There is a shortcut and a quick way of finding the overall answer if you're required to find a hypotenuse followed by another hypotenuse, and that would be to do the square root of 4 squared plus 8 squared using the 2 original lengths, and then the result of this, which was 80, is then being added on to 3 squared before being square rooted. So we can represent that all under the same square root like this, and typing that straight into your calculator would give us 9.43. For the next question, find the exact length of RT. This is the type of question that would appear on a non-calculator paper. RT runs from here to here, and I can use this right angled triangle to help me. I can also use the right angled triangle across the base, which has the shared length of RP. And since I would be required to find the hypotenuse of the blue one before finding the hypotenuse of the red one, the hypotenuse twice will allow me to use the shortcut that I used previously. So the square root of the 2 lengths on the blue triangle, 12 squared plus 5 squared, and then the result of that would be added to the length on the red triangle, this one over here, which would be the same as 9 millimeters, so adding 9 squared. Simplifying this without a calculator, 12 squared is 144, 5 squared is 25, and 9 squared is 81. Adding these together gives me the square root of 250, and I can simplify this using my knowledge of surds. Root 250 can be represented as root 25 multiplied by root 10, which will give me a final answer of 5 root 10 millimeters. On to the intermediate question with a slight increase in difficulty. The length AB is 7 centimeters, A to F is 5 centimeters, and F to C, which is given as the diagonal length from here to here, measures 15 centimeters. Calculate the volume of the cuboid, giving our answers to 3 significant figures. We'll need to multiply the length, the width, and the depth to work out the volume of the cuboid. We already have the length and the width, but we'll need to work out the depth. Using the length FC, F to A, and A to C, I can form a right angled triangle, which will allow me to work out the length A to C, which forms a shared length with this right angled triangle across the base. This will then allow me to work out the depth labelled as CB. So using Pythagoras with the triangle coloured red, the hypotenuse is known. So to find out one of the shorter lengths, I'll need to square 15 and subtract 5 squared before square rooting, which is 10 root 2. This is a shared length with this one here, meaning I can use Pythagoras again with the blue triangle. Again, the hypotenuse is known. So 10 root 2 squared minus 7 squared is the square root of 151. Therefore, to find the volume, I can do the length of 5 centimeters multiplied by the width of 7 multiplied by the depth, which has just been calculated to be the square root of 151. This gives me 430.09, which is 430 centimeters cubed to 3 significant figures. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. A square-based pyramid has a base of side 4.8 centimeters, meaning each of the base lengths are the same, and sloped edges of 11.2 centimeters. Find the volume of the pyramid to 2 decimal places. The volume of any pyramid can be found by doing a third multiplied by the base area, which in this case would be represented by the square at the base of the pyramid, multiplied by the height of the pyramid, which would go from the vertex at the top down to the middle of the base of the pyramid. I can actually work out the base area quite quickly since this is just a square. 4.8 squared, or 4.8 times 4.8, is 23.04. So the volume of the pyramid will be a third multiplied by 23.04 multiplied by the height. The height is the part where I'll have to use Pythagoras to help me. Using the right angle triangle highlighted blue, with a hypotenuse of 11.2, the height is what I'm trying to work out, but the other shorter length can be found by considering another right angle triangle with a shared length. This right angle triangle here. This one is my shared length which forms the hypotenuse. I know that the whole lengths of the base are 4.8 centimeters, so the orange triangle which goes halfway through to the midpoint will be shorter lengths of 2.4. I can use these along with Pythagoras' theorem. Since I'm finding the hypotenuse, I can do the square root of 2.4 squared plus 2.4 squared, which gives me 3.39. And since the question's asking us to round to 2 decimal places, I should always use at least 3 decimal places until I get to my final calculation and answer. So 3.394. That means this length is 3.394, which is shared with the length on the blue triangle, which then allows me to find the missing height from the blue triangle, which is the height of the pyramid. So using Pythagoras again, this time the hypotenuse is known. So the square root of 11.2 squared minus 3.394 squared, which is 10.673. This is the height of the pyramid. So using my calculator, a third of 23.04 multiplied by 10.673 is 81.97 centimeters cubed. Here's a question that I've completed already. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are, or make some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.